Hi guys. We're going to see angle relationships between different angles that are formed when a transversal intersects two parallel lines. All right. And for seeing this, we're going to assume there are two parallel lines. Let's say L and M. These are the two parallel lines, and P here is a transversal intersecting both of them. All right. Now, as you can see, when P intersects L and M, a total number of 8 angles are formed, 4 at each vertex. So I'm just going to label them quickly for our convenience. Let's call it 1, 2. Just for ease, I'm labeling them with numbers. It's not the way usually angles are labeled, but for the sake of this video, just label them with numbers, all right? Okay. Now, when line P intersects the parallel lines L and M, is called a transversal because it's meeting at two distinct points. Uh, it ends up forming these 8 angles. Okay, and there are some very interesting relationships which emerge from in between these angles if L and M are parallel. All right. To explore the first relationship, we're going to take angles 2 and 6. Okay, angles 2 and angle 6. Now, when we look at this particular diagram, we can see that angle 2 and angle 6 look kind of equal, right? And if you think of it in this way, like if angle 2 and 6 were not equal, would lines L and M be parallel? That's an interesting question to explore, okay? And that's what we're going to do first. Now, whenever a transversal intersects two lines, these angles have certain names, all right? Like 2 and 6 are called corresponding angles. 1 and 5 are also corresponding angles. 4 and 8 are corresponding angles. 3 and 7 are corresponding angles, okay? Now we're going to go inside and see like what is the special relationship that happens with these corresponding angles when the lines are parallel, okay? Now let's think. Now intuitively, I can feel that if 2 and 6 were not equal, if 2 and 6 angle 2 and angle 6 were not equal, maybe these two lines would have not been parallel. All right. So I'm going to just explore that a little bit, and I'm going to see if what happens if corresponding angles are not equal. Okay. So let's say if 2 and 6 are not equal. Okay. Uh, like suppose angle 2, like it leads to two cases, like angle 2 can be greater than angle 6 or angle 6 can be greater than angle 2. All right, either of these two can happen. Okay, let's go into angle 2 being greater than angle 6. What happens in that case? Okay, I'm just going to redraw this a little bit here. Let's say this is P, this is the transversal. I'm just going to take this part of the ray. Angle 2 is greater than angle 6. Okay, I'm just assuming angle 6 is similar to how it was in the diagram above. Okay, this is angle 6. Okay, and angle 2 is greater, which means this measure of rotation is going to be more than the rotation of line M. Okay, it's going to be more than the rotation of line M with respect to line P. So line L is going to rotate more than line M. Okay, so I'm ending up rotating it more for angle 2. Okay, which means in this side these are going in away, but if you see towards this side, because 2 has rotated more than angle 6, it goes together and ends up intersecting at a point. All right, it ends up intersecting at some point here, which means the lines L and M are no longer going to be parallel, which means if these two if angle 2 is greater than angle 6, lines L and M will not be parallel. Okay, lines L and M will not be parallel. Okay, let's see what happens. Similarly, let's see what happens if 6 is greater than angle 2. Okay, so angle 6. So let's draw angle 2 here. This is angle 2. This is the amount of rotation that's happening for angle 2, or or line L with respect to line P. Okay. Now angle 6, that is the rotation of line M with respect to line P. Now if this rotation is more, if this rotation is more than how much angle 2 was rotating, okay, so I'm making this rotation more, and consequently this M is going to, like here we can see is going far away from these two lines are going far away on this side. But if you see this side, and if I extend it to this side, like somewhere here these two lines are going to meet. Okay, the diagram is not perfect, but you can imagine, right? Like these two lines are going to meet somewhere here, like far away maybe, but they are going to meet. Angle 6 and angle 2 are going to meet if angle 6 is more than angle 2. If the rotation of this part is more than this part, then they are going to intersect on this side, okay? Which means again L will not be parallel to M. L will not be parallel to M. Now let's see what happens if these two are equal, okay? Let's just think about it for a minute. If angle 2 and angle 6 are equal, then this is P, this is the transversal. Now this, that's the line L, is rotating this much. Line M is also rotating the same amount, okay? The same amount. So angle 2 and angle 6 are equal, which makes us think, okay, because these are rotating the same amount, with respect to P, they are going away in the same direction. And since they are going to go away in the same direction, not coming closer, not going further, which means the distance between them is going to be the same at all times. The distance between them is going to be the same at all times, which means L is going to be parallel to M. Okay, L is going to be parallel to M, and this is a very intuitive understanding, and that's why mathematicians call it an axiom. And this is called the corresponding angles axiom for parallel lines and a transversal. And here we have an axiom with us. Okay, we have like this axiom can be stated in this way. The axiom can be, if a transversal intersects two parallel lines, if a transversal intersects two parallel lines, then the pair of corresponding angles the pairs of corresponding angles, because here we have taken 2 and 6, but you can also see that angle 1 and angle 5 are also forming a corresponding pair. 4 and 8 are forming a corresponding pair. So are 3 and 7. Okay, the pairs of corresponding angles formed are equal. Okay, are equal. So this is my axiom here, which I'm getting from an intuitive understanding, just by imagining, just by using my reason to imagine what would happen if they were not equal. Okay, that would mean that these two lines would not be parallel at all right, let's think about this for a minute, okay? And then maybe you can pause and think about this for a minute, and then let's think about what it would be the converse of this axiom, okay? And would the converse also be true? Let's think about that now. All right, now the converse of this axiom, let me state that axiom first, okay? And let's see whether it's true or not, okay? The converse, okay? I'm going to state the converse of this. If a pair of corresponding angles, if a pair of corresponding angles is equal, or you can say when a transversal intersects two lines, then those two lines are parallel. Then those two lines are parallel. Okay, there is no doubt about this. And let's see how can we be so sure about that? Okay, let's just draw a diagram for that again. Now this is we don't know whether these two lines, let's say these are lines X and Y, we don't know whether they are parallel or not. But let's suppose there's a transversal Z here, and this angle is 70 degrees, and so is this angle 70 degrees. If these were not equal, what would have happened if these were not equal? Like if these were not equal, if even if one of them was 1 degree different, or 0.1 degrees different, on one side or the other they would have ended up meeting, right? Either this side or this side, they would have met some, either on either this side or that side. All right, but that's not the case. They are equal, and that is why they are going to continue going in the same direction, okay? And the distance between these two lines is going to be same, which means they are going to be, X is going to be parallel to Y. All right, okay? So this is also this is just an intuitive understanding of the axiom, again the converse of the axiom. All right, so this is a first relationship which we come up with, okay, whenever we look at parallel lines and a transversal. And if you look closely, there are actually more interesting relationships emerging. Okay, let's write this down first. Let's write what we get from the corresponding angles axiom. Okay, this is our first axiom, which is corresponding angles axiom. Okay, let us name it like this. I am not sure if it is named like this is the proper name in maths, but it's okay. Like for our understanding, we'll go ahead with calling it corresponding angles axiom, and we can see that from this we are getting these relationships. Okay, that's angle 2 is equal to angle 6. In this diagram we are assuming that L is parallel to M. Okay, if we are assuming that, then angle 2 has to be equal to angle 6, angle 1 has to be equal to angle 5, angle 4 has to be equal to angle 8, and angle 3 has to be equal to angle 7. All right, now these are the four relationships we are getting from this diagram if we consider the corresponding angles axiom. All right, now I'm going to build off on that, and we're going to go back a little bit to the vertically opposite angles theorem. Okay, if we see carefully, angle 2 is actually vertically opposite to angle 4. When lines P and L are intersecting, 2 and 4 are automatically equal, because vertically opposite angles theorem states that whenever two lines intersect, the angles opposite to each other at the vertex are going to be equal, which means 2 and 4 here are going to be equal, which means 6, 2, 4, and 8 are all equal. If you see, 6 is also equal to 8, right? Because 6 is again vertically opposite to 8. Okay, so 6 is also equal to 8. So basically, what I'm ending up is I'm essentially proving that angle 2 is equal. I'm just going to write it in green so that it's similar. Okay, so basically, I'm essentially proving that angle 2 is equal to angle 4 is equal to angle 6 is equal to angle 8. Okay, and if you look closely, there is a similar relationship formed by the rest of the angles, angle 1 and angle 5. So if you see here, angle 1 and angle 5 are corresponding again. 1 and 3 are vertically opposite, 5 and 7 are vertically opposite, which means 1 is equal to 5. We have already shown that by the corresponding angles axiom. We have already shown that here by the corresponding angles axiom. And 3 is equal to 7, we've already shown that. At the same time, we can understand that 1 is equal to 3, 5 is equal to 7. So basically, another relationship which we are getting here, angle 1 is equal to angle 3 is equal to angle 5 is equal to angle 7. Okay, if and only if L is parallel to M, then this is true. Okay, only if L is parallel to M, then this thing is true. Then this whole thing is true. Okay, otherwise it's not going to happen, because if L is not parallel, our axiom would be false. Like we would not get angle 2 and angle 6 equal, and hence all of this might not happen. Okay, yes, 2 will be equal to 4, but there will be no relationship between 2 and 6, so we'll not be able to arrive here. We'll not be able to arrive here. All right. So this is one of the most important results, which are one of the most important results which are going to help us in as a building block in further geometry. Okay, when we use lines and angles and explore it further. All right. Now this is one part of it. There's one another very interesting relationship being formed here. All right, and I'm just going to zoom out a little bit to focus on that relationship. Uh, let's see the relationship between angles 3 and 6. Okay, all right, before we go into that, let's just close this up. Let's just see what is the labeling. What are these things called? Okay, now if you see angle 4 and angle 6, let's first focus on angle 4 and angle 6. Now angle 4 and angle 6 are both on the inside. Okay, actually angle 4, angle 6, angle 3, and angle 5, these are all called interior angles. Okay, these are all called interior angles, and there is a special relationship between 4 and 6. You can see that 4 and 6 are also turning out to be equal. They are called alternate interior angles. Okay, they are called alternate interior angles. And if you can see, when the lines are parallel, alternate interior angles also turn out to be equal. We have already shown it here. 4 is equal to 6. We have shown that here. We have also shown that 3 is equal to 5 here. So alternate interior angle pairs are equal. So I'm just going to write down this theorem. Angle 4 is equal to angle 6 and angle 5 is equal to angle 3. Okay, so this is the alternate interior angles theorem, and maybe I can state it in a better way right now. If I'm going to state it now, this is going to be a theorem and I'm going to show you why. Okay, so if a transversal intersects two parallel lines, then the pairs of alternate interior angles are equal. Now, this is not something which we can intuitively believe, but something which we need a systematic proof for. And I've just told you that before, like how we did the vertically opposite angles part. We can do a systematic proof for this also, not getting into that route. Like you just have to just equate two equations here. Okay. So, this is the theorem. This might be called the alternate interior angles theorem. Okay, it's just a theorem and it needs to be proved, and we have just proved that and got until here. Okay, we've got that from the vertically opposite angles understanding. All right. Now, same way, there is another relationship. It's called the alternate exterior angles. Okay, alternate exterior angles. If you look closely again, exterior angles are 1, 2, 8, and 7 as they are lying on the outside of both transversals. If we say that 4, 3, 5, and 6 were on the inside. So here also, angle 1 is equal to angle 7. Alternate exterior angles are equal, and angle 2 is equal to angle 8. In fact, if you see this, all these 4 green spots are same, 4 green angles are same, and 4 red angles are same. All right. So basically, this can also be stated in a similar way. Okay, if a transversal intersects two parallel lines, then the pairs of alternate exterior angles are equal. Okay, so that's how that's giving us very interesting three different relationships. And I'm going to go into one more interesting but different relationship from all of this. Okay, I'm going to go into one more relationship, and that's between interior angles on the same side of the transversal. Okay, let's see this part. Interior angles on the same side of the transversal. Okay, now let's look closely in this let's look closely on this diagram. Okay, let's look closely into this diagram. Same side of the transversal and interior, that is angle 3 and angle 6. Okay, that's on the same side. One other pair is angle 4 and angle 5. Okay, these are both on the same side of the transversal and are interior. Okay, so what's the relationship between them? Very curious, very interesting relationship emerges from this. Okay, very interesting result. If we look closely, angle 1 and angle 4 are supplementary. Okay, they are forming a linear pair. Okay, at the same time, angle 1 is actually equal to angle 5, which means I can actually substitute 5 in this equation. Okay, I can substitute 5 in place of 1, and what I get is angle 5 plus angle 4 is 180 degree. Okay, which means interior angles on the same side of the transversal, excuse me here, on the same side of the transversal are supplementary. Okay, are supplementary, but note this very well. This will happen only, again, we have built our entire discussion assuming that L and M are parallel. Okay, if the two lines are parallel, and that's only when we'll get this result as well. Okay, so interior angles are supplementary. We can do the same thing for angle 3 and angle 6. You can substitute the same way. Angle 3 plus angle 2 is equal to 180 degrees, and you can substitute 5 in place. You can substitute 6 in place of 2. You can substitute 6 here because angle 2 and angle 6 are equal. We already shown that here. So angle 6 and angle 2 are equal. So I'm going to just substitute angle 6 here. So angle 3 plus angle 2 is equal to 180 degree. Okay, now this is another whole different result. Okay, interior angles on the same side of the transversal are supplementary. And if you think about it, you can do the same thing for exterior angles as well. Okay, you can do the same thing for exterior angles as well. If you can see the red angle plus the green angle in this diagram over here, the red angle plus the green angle is coming to 180 degree, and if you look closely, 1 plus 8 is going to again come to 180 degree. Okay, maybe try this proof out yourself similar way. Okay, so these are all the results we are going to which we are going to be needing for going into finding playing around with more problems of lines and angles. All right, thank you guys.
Okay, so just summing up all the results here, when a transversal intersects a pair of parallel lines, the corresponding angles are going to be equal. We have seen that the corresponding angles are going to be equal. The alternate interior angle pairs are going to be equal. The alternate exterior angle pairs are going to be equal. The interior angles on the same side of the transversal are going to add up to 180 degree. So are the exterior angles on the same side of the transversal, that is angle 1 plus angle 8 is going to be 180 degree, and angle 2 plus angle 7 is also going to be 180 degree. Okay, this is all the angle relationships which are possible when one transversal intersects a pair of parallel lines between those eight angles. All right, thank you guys, that will be all.